Flipped Classroom video for Maths AS Unit 1, Geometry of Lines, Applications. So we're going to do some examples in this video, and if you've been through the previous video, which was looking at formulae for the three different forms of the equation of a line, then this will be quite nice because you'll be able to actually use those in some numerical situations. So the first question is, we're given the coordinates of 2 points A and B, and they are 5, 11 and -3, 9, and we're asked to calculate the length of that line. So express your answer as a surd in its simplified form, A root B. Okay, now it's always a good idea to do a sketch in these questions, and you'll see that the sketch I'm doing is very rough, but it does give me a rough idea of whether I'm getting the question at least towards the right sort of answer. And for more complicated questions, it can be very useful in showing us where particular geometrical features are. Okay, so good idea to practice rough sketches. So there's our axes, and I've done them like that because I can see that I've got quite high y numbers and the x numbers are relatively close to 0. So I pop my points on, and because it's about the length of the line, I know I'm going to be doing a Pythagoras, so I've jotted that onto the diagram. And actually most of the information I need, all of the information I need in fact, is on there, but we'll go through the algebra anyway. So the length squared is going to be the change in x squared plus the change in y squared, and that means that the length of AB squared, and notice that those two lines either side of a thing tell us that we're looking at the size of it. So when we put those lines, they're called modulus lines, when we put them around AB, we're talking about the length of AB. So the length of AB squared is going to be the difference between the x coordinates, so that's 5 take away -3 squared, plus the difference between the y coordinates, so that's 11 minus 9 squared. We then tidy that up. 5 take away -3 is 8, so 8 squared. 11 take away 9 is 2, so that gives us 2 squared. And that gives us 64 plus 4, which is 68. Now they want it in simplified form, and notice we could have taken a square factor out before we got to 68. We will probably recognise that both 64 and 4 divide by 4, so that's going to be a factor. And in fact, we can split 68 into 4 times 17, and then the root 4 becomes 2 outside the square root. 17 is a prime number, so it can't be simplified any further, and we end up with the length of AB is 2 root 17. And on GeoGebra there's a nicer picture of it. The 8.25 is of course the decimal version, and that's a reasonable answer, so it will be worth checking the 2 root 17 on your calculator anyway, because if we imagine the length of 8 sort of swinging upwards or extending upwards to give us our line AB, it wouldn't add that much to the length, just lifting it up by 2, so we can be happy with our answer of 8.25. Okay, carrying on, we've got the same points, but this example we're going to be looking at parallel lines, and we're going to use slope point form. So we've got the same coordinates, and this time they're asking for the equation of the line that's parallel to AB, so using the parallel property, and it passes through 2, 7. And we have to express our answer in the form y equals mx plus c. Okay, so if we do ourselves a little sketch, there's our axes, there's our points, and we want another point, 2, 7, and we want a parallel line to go through it. So that's what we're aiming for. So breaking this down into steps, the first step is to find the gradient of AB. We want the line parallel to AB, so we need to know the gradient of AB itself, of course, and to find the gradient we need the change in y, the rise, divided by the change in x, the run. So the change in y, as we know from before, is our 11 take away 9, which is 2, and the change in x is 5 take away -3, which is 8, so that gives us 2 over 8, which is 1/4. Now we use slope point to start finding the equation of the line, and this is where slope point is so useful. We now know the gradient, 1/4. We know a point on the line, 2, 7, and so we can pop all that in. That's our general slope point, y minus y1 equals mx minus x1, and we pop our numbers in, and we have y minus 7, which is the y coordinate of the point, is 1/4, the gradient, times x minus 2, which was the x coordinate of the point. So we've now got our line, but the question asks us to express it in the form y equals mx plus c. So step 3 is to convert slope point into y equals mx plus c. So first of all we can add 7 to both sides, so we've now got y equals, and then we'll have to tidy up those numbers. So we have minus 1/2 plus 7, which is going to be 14 over 2, take away 1 over 2, which is 13 over 2. So we now have y is 1/4 x plus 13 over 2, and we can see that on our GeoGebra clip, or screenshot I should say, and that looks fairly similar to our sketch. So our sketch was useful in giving us a picture of what's going on, particularly if this question then went on to some other things that it was asking you. We can see that from the GeoGebra the intercept is 6.5, which is our 13 over 2. In fact, there is our answer, 1/4 x plus 13 over 2 is fine, we don't need to put it into decimals, but if we did, of course, we'd have 0.25x plus 6.5, and so we can see that that's all tickety-boo. Okay, moving on to the next example, and this one uses the midpoint, perpendicular lines and standard form. So we have our same points again. This time we're being asked to find the equation of the straight line perpendicular to AB that passes through the midpoint of AB. And we have to express our answer in the form ax plus by equals c, which is of course standard form. So, step 1, again we have to find the gradient of AB, so that's just the same as we did before because we are using the same points, and so as we know that comes out as 1/4. Step 2, we need to find the gradient of the perpendicular. Now we know that the gradient of our line, so that's ml, is going to be minus 1 over the gradient of the line that we need it to be perpendicular to, which is MAB. We can pop our 1/4 in there, so that's minus 1 divided by 1/4 times top and bottom by 4, and that gives us minus 4. So the gradient of our perpendicular must be minus 4. We also need now to find the midpoint of AB because we've got the gradient, but if we're going to use slope point form, then we need a point, and that point that it goes through is the midpoint of AB. And we know from before that to get the midpoint we need the average value of the x-coordinates, so that's xa plus xb over 2, and the average of the y's, so that's ya plus yb over 2. And we can pop those numbers in, 5 plus minus 3 over 2, and 11 plus 9 over 2, and 5 plus minus 3 is 2, divided by 2 is 1, 11 plus 9 is 20, divided by 2 is 10, so our midpoint is 1, 10. Now we find the equation of the line, and we start with our y minus y1 is mx minus x1 because we've got our slope, which is minus 4, and we have our midpoint, or our point on the line, which is 1, 10. So pop those in, we get y minus 10 is minus 4x minus 1. We want to put that in an ax plus by equals c form. So first of all, open up the bracket. So that's going to be minus 4x plus 4. The minus 4x can go to the other side by adding 4x on. So that gives us 4x plus y. And if we add 10 to both sides at the same time, we end up with 14 on the right hand side. And we can have a look at a diagram of that. There's quite a few features on there. Our original line is in red, and we can see our gradient on there of 0.25. Our perpendicular is in green, and we can see its gradient of minus 4. We can also see that our midpoint is 110, and that looks nice. I haven't done a sketch on this question because of lack of room on the page, but hopefully you were doing a sketch or will do a sketch when you work through the question. And the final thing I want to just mention on this is that although this question is asked for ax plus by equals c, you may remember that sometimes standard form is asked for in terms ax plus by plus c equals 0, and so of course we would get that by subtracting 14 from both sides from the answer we gave before, and that would have given us 4x plus y minus 14 equals 0.